Hello. Okay, let me just see. Um, how do I go? Okay. Just give me a second. I'm just trying to load the comments and stuff. I mean, sorry. What is that? Chat. I'm trying to load the chat. YouTube Leasy channel en direct. Oui, c'est ça. Ok. Mm, that's good. Okay. And then okay, let me check the quality of the voice in channel because I mean the voice quality is a little bit off, but I don't know how to make it better. Well, I think it's just the quality of my microphone. It doesn't get anywhere. That's what it is. Wow. Anyway, let's go back to okay. So where am I hearing? Okay. So the thing today is that I just started a project. Um, it's a small, I don't know how big it's gonna grow, but it's a small project. Generally, it's to learn Mach Engine in Zig, and I will try to use WebGPU. And then yeah, that's the thing. And I really have no idea how what WebGPU is, so it's it would be good for it would be a good experience for me, and I hope that yeah, you can join in and we can share this experience learning WebGPU and yeah, have some fun. And at the same time, I am going to. Oh, okay. So first thing, how do we create this Mach Engine project in Zig? Because it's a pain. There is no. So normally every library in Zig they have some kind of an example to show you how to do things. Like you do this, you write this like git zig the fetch, I don't know, save command, and then you run that command, and then you get your project running, and that's just gonna work with. Uh, Here, if you go to the page of the Mach Engine, this thing doesn't exist there. And then yeah, the examples that they put, they don't put the build.zig and build.zig.son. So it's a little bit confusing, like especially build.zig for Mach Engine is a bit different, and for me who is not um, really good at writing the build.zig, this is it's a bit annoying. It takes time to realize how to do it. I had to ask help from AI. Just a second. I just go check on my birds. Okay, sorry, I'm back. So yeah, where were we? Okay, how do we make the project? So the first thing I did was to um. So basically, there is just this command zig init. It creates the essentials for the project, and then we use zig fetch dash dash save. We write git plus and then the URL of the git page, the main page of our library, the Mach library. Um, and then we type it there, and it will add it to our build.zone, and it will be okay. And then we have to write the build.zig, but build.zig has to be we can just write it in a simple way, because there are different ways to write build.zig for um, um, for Mach, but this is the way that I made it run for now. It's just I add it as a dependency, and I run my main.zig as usual. And the thing is that this is a zig 0.14 because Mach Engine runs on zig 0.14, so I had to download the zig file separately since zigup doesn't work for some reason. Yeah, and the rest are the same. I just add the mock as a dependency library. That's it. And now it's running. So I took the example. There are some examples in the page. If you go to their GitHub page, um, there are some examples, and yeah, this is a triangle example that I'm taking using Mach.gpu is just basically WebGPU, and it does many of the things that you want it to do. You will have a window. There's no need to have any concerns about that, and then it's gonna work. So, and you have a shader and a bit, let's say, and then I run zig14 build run. Gonna take a while, the completion. So okay, let me see if you can see this result. No, you can't. So I have to add zrun. Okay, now you can see only a black screen. Properties, not automatic. Make it Windows 10. Okay, very good. So you can see the result. It's a window. Of course, it has a title bar, but for some reason I can't understand how to make it this OBS show the title bar. So yeah. So, and that's the result of the code of the example in there. This is a triangle example. Now I'm trying to understand how is this happening? Like what does this thing like? what makes this triangle to show. I have absolutely no idea about WebGPU generally, so I'm reading a lot of stuff like at the same time from AI. I'm using AI to understand. Like I'm asking questions like, what is this? So for example, until now, I have understood that in app.zig we are calling um, where is app.zig? We are calling uh, so here we are making the pipeline, set of pipeline, and then there is a tick function. We make a background color, render pass color attachment. Okay, there is this draw function here, render pass. So we create a I don't exactly know what is this render pass, but we kind of create a context, I guess, where we can put with the background color of this color, and then we use this context um, to draw. Now we send these things like there is draw and then there is 100. So I don't know what is 100, but apparently this 3 uh, tells the GPU to call this vertex main function in the mm, yeah web GPU shader language to be run 3 times, and then so each time with the vertex index 0, 1, 2, for example, and then each time we come here, we take the position of the vertex index. So for example, 0.5 and then 0 and 1. This will be a 4-dimensional vector. That's the position. This is the z, this is x, y, and this is the z. And this is scale of it is the scaling parameter as it was written. I don't exactly know what this is. Again, I have to read these things like what are these things? I think I have to go to probably some documentation on WebGPU to understand these things better. And then yeah, that's the main thing that's happening. And then frag main is so for each pixel this function is gonna be run is gonna run, and then the GPU itself is gonna connect the things together and make a shape with this vector with this positions. So basically we are trying to draw a polygon, I guess, and we are passing the position each time, but this is happening in parallel in GPU. That's like what I've learned. I don't know how much of this is true. And then we have this frag main, which gives us the color of which is the yellow. So yeah, that's okay. Um, so let me go see if I can open documentation for WebGPU documentation. I need, okay, let's go back to our, so we have the vertex index, and then vertex index, run your vertex main function. Okay, this is the key. Node 2 and okay. It would run once, generate 1 point, and run nothing. Okay, so 2 points will generate a line. But only if you tell GPU I'm drawing lines. Right now your code is set to triangle list mode. Point this, how to make it in code. Primitive field to the pipeline descriptor. Draw call. You are in line mode, you only need to ask for 2 vertices. Now what is 1 by the way? Instance count. Okay, instance counts first vertex, first instance. Here is what that means in plain English. Okay, can I go after the grow? I wish I had the. So a Zig language server is not working properly, I guess, because I cannot go to the definition of grow. Okay, I think it's just a binding from some kind of a draw function in WebGPU. So I wouldn't be able to get the definition now. There is the vertex count, instance count, and first vertex, first instance. Here what that means in plain English, the rubber stamp analogy. Draw command as using a rubber stamp. Okay, vertex count 2 defines the shape of the stamp. 2 points. Instance count defines how many times stamp that shape on onto the paper. This one GPU draws your shape once 100 times in a single command. This is incredibly fast and is used for things like grass, frost, forests, or particles where you need thousands of identical copies. Okay. Start reading the array from which index, usually 0, the counting instance from what number 0. Oh, okay, these are the indices. Okay, so this row tells GPU to call this vertex main 3 times. So each time it's gonna call it with some vertex index, built-in vertex index, and 0, 1, 2. Okay, if I put 5, it's gonna go 0, 1, 2, 3, 4. And then the second one was how many times this row call is gonna be called, basically. No, sorry, how many times this process has to be repeated. So for example, if you want to draw some shape multiple times, okay, and then this is which vertex index, like the starting vertex index that we put here is 0, and generally it's 0, and 0 here for starting like index of the whole process. Like if we have multiple process, which process should go first? Okay, so that's the draw function. So draw has vertex count, vertex count, instance count, or call count, starting vertex, starting instance. Or a starting call. Instance is a better choice than call. Instance count. How many times the process should be repeated. Okay. Then if I'm doing that, then I do end, basically this is the end of drawing, I guess. And the rest are just to finish everything that's left. Oh, okay. And then we go to the shader. So there are multiple things that I have a question on. So first thing, okay, so here we are saying that we want to use the built-in vertex index. Okay, I guess there are some built-in stuff that we can use. There is the built-in um, position of the pixel that we are processing, basically, right? Okay, and then we are here creating some array, but then there is the definition is a little bit, I don't know, it's a little bit weird. So this is the length of this array. It's three. The array has three entries. So there is the first vector, second vector, third vector. So it's a vector of f32, and the length of this vector, this array is three, right? Here we are passing. Oh, okay. We are passing like the value of this array, like which vector of position is it for x and y, and then z is just another one. But then how is it the vector four-dimensional vector? Because this is just a three-dimensional vector, but the first no, I mean it's a three-valued vector that has the first element has two, like it's a it's a vector of two dimension. I don't understand how. I guess this is automatically being processed in WebGSL. What? Well, yeah. Let me ask this. So, okay, okay, 2 1 1, right? And then so vertex main will return the, so we do the calculation for vertex positions, and we return it by vertex main function each time. And frag main is the color. So for example, if I do, so my frag main, can it have some here, for example, can I do built-in, not position, but built-in built-in vertex index. Okay, and then I will do some variable. Why? Oh, vec for, no, var, and then this thing is color, which is vec for f32, and then so vertex index, I'm gonna assume that casting from U32 to F32 is automatic. So I'm gonna just do, so for example, is it correct to say vertex index multiplied to, for example, 0.3? This is gonna be 0, 1, 2, Yeah, it's okay. It's not gonna be over 1. And then 0.5, 0.2. And what is 1? I'm assuming 1 is alpha. So I can do also vertex multiplied by vertex index. That is so bad that I don't have the. Oh, this is a WGSL. Okay, but there is no formatting for WGSL for some reason. Okay, it doesn't work. Here I want to return the color. Will this work or it's gonna give us error? I will try to find the WGSL documentation. Documentation. New shader language. Okay. No, there was a. I think there was an error somehow. Failed with exit code 1, so it didn't run, but I don't have the error details on why this returned. Oh, okay, here. So primary monitor work here. Okay, error use of undeclared identifier vertex index. Where? So fragment doesn't have the position, right? Yeah, okay, so this thing, when I'm calling it, oh no, it's here. Okay, so this thing has to be underlined. Okay, I see. Try to run this again. Yeah, and at the same time, I'm gonna try to find some documentation for the shader language. From storage buffer. Yeah, there was error, another error because it didn't show the window. Use of undeclared identifier vertex index. Okay. I mean, it's been declared here, no? Built-in vertex index. What's happening? Let me try to understand what's going on. Um, Shader language for WebGPU, that is an application using WebGPU API uses WebGSL to express the program known as shaders that run on the GPU. Binding, okay, you define variables, fragment main. Function arguments are values from the vertex shader. Location 1 normal, location 2. Um, so let me go back to this code. There was a location. Okay, there is a location 0. How can I have access to this vertex index? I have to ask AI, I guess. It sees two numbers, one number, one number. It concatenates them like this. The result is a single vector of 4 components. There is a depth perspective weight. What is a perspective weight, by the way? W, after your vertex finishes, the GPU automatically performs a perceptive divide. Okay, so W is this kind of a scale. It's kind of a scale factor. So yeah, what I'm talking about is that here I'm returning a 4-dimensional vector. So for 3D graphic, it would be the 3 first number of the position like X, Y, and Z. And the last one is called the weight, perceptive weight. Basically, it's the scale of the shape in 3-dimensional um, programming. It's needed, but since we're gonna do 2-dimensional programming in general, we essentially we're not gonna try to change this for now, at least for now. And then this thing, of course, the very position, this thing is a 2-dimensional vector itself, but it automatically concatenates this thing, so there is no problem there. So I'm assuming also U32 is gonna be converted to F32 really easily. But we will have to see that too. So let me check now. Okay, so now I want to pass vertex index to fragment. How can I access to vertex index in fragment? And can I change the fragment function name, or they are fixed? So in case you're wondering, I'm asking AI all these questions, and I'm not showing it on the screen just because I don't know the. So I know that I can do this, but I don't know how far I can show everything, the details and stuff. Like depending on the AI, there could be terms of use and stuff. In general, it should be okay, but I don't know. I haven't been checking that. So fragment or vertex main are just arbitrary names we choose. We can call them pixel shader, whatever we want. Okay, inside the setup pipeline, look for entry fields. So okay, there is the tick vertex main entry. Okay, I see. Fragment, very good. Fragment. Okay, this is a fragment state init. It's this one. Targets this one. Module. This is the vertex. It's this one. Label. Okay, I see. So these are so so I have to go back to documentation. Here they define a struct here. Mm, tag name, Mach module, app.pipeline. Okay, so here I'm defining the, okay, so fragment is pixel color, color pixel, color pixel. It's a better function name. And I do not use underline for function names, so locate pixel. So pixel is with EL, right? Okay, it's EL. I mean, I guess. So here I need to change the vertex main to locate pixel, and this one is color pixel. So it's more telling now. This is to locate. What is the location? Get pixel location, I guess, and or get vertex. Get a vertex location. This is a better function name. Here, get vertex location. Get vertex color. Exactly. Okay, very good. Even though I don't have a, I mean, if I had um, the ZLS working here, the Zig language server working, I would have auto suggestion, auto completion better. I guess I will have some options to look at, like to see what are the functions that exist and stuff, and to predict sometimes what could be used and stuff. But then I guess because there is this Z has this code generator that is like it feels good to have it. You don't miss as much. Okay, so we have the vertex color and location, and we pass this thing. So can I? How do I say, for example, that I want to give a number to this function? So this vertex color. Let me just run this just a second. Um, I will just copy this. How do you write comments in? It's double slash. Okay. 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 So here I'm gonna just turn it back to how it was, and then instead, okay, I just want to see if this works with the changing of the names to be sure. Okay, there is still error. Why is it error? Function name, pipeline core, pipeline descriptor. Okay, where is it? These things. Maybe these are mentioned in other places also. No, I don't have them anywhere else. So let me ask AI, can I just change the name of these functions without any error? Frag main and vertex main are just arbitrary names. Yeah, but when I change them, there is an error. We cannot access this directly in fragment shader. That variable only exists while the GPU is processing the geometry vertex stage. To use it in a pixel coloring stage, you must pass it manually from vertex shader to the fragment shader. You can do this by creating a struct that holds both the mandatory position and your custom data. Position, location, index, color. Uh, there's a vertex output. Index color is that. And then you can use it in frag main. Okay, they use F32, okay. Frag main. Okay, I still don't understand. I mean, I get it, but I don't get it at the same time. Name for functions. There is error. Oh, what was the error, by the way? I didn't even pay attention. I assumed that it was just something with the names. And target error invalid VS51 output semantic API error. Vertex module. That's this vertex entry point VS51. I guess these are module names. These are fixed names, no? I mean, in their documentation page. So, for example, okay, maybe I can do. It's okay. Another fragment main function. Let me just copy paste the error for AI. Maybe he knows what's going on. Hey, how are you doing? Sean Tyson? Is that correct? I hope I pronounced the name right. Welcome to the chat. Trying to compile a fragment shader as a vertex shader. Uh, really? No, but this is, oh yeah, okay, so this is fragment. This is get fragments color. Okay, this is get vertex location. That's why. Wow. Okay, this is a vertex, so it needs a vertex. Now it should work. Yeah, that's your name. Okay. Welcome to the chat and stream. It's gonna take a while. Okay, it runs and there's error. What is the error now? Entry point not found. Get fragment color. Vertex location. Oh, vertex color. This is a vertex color. Location. I'm gonna make a. So maybe it's a good idea to change the names. This is fragment color. Okay. Now it should be okay. So this is okay. Now it's okay now. So this is cool. This works. And okay. So the name of the functions can be decided by us. That's cool. Now I want to know what is this location 0? What does this mean here? Um, what does location 0 mean? There is fragments, location, world position, or okay, let me show cursor just here. So I don't understand what is this group stuff. The GPU issues a unit of work to the GPU in the form of GPU command and stuff. Draw command executes a render pipeline in the context of inputs and outputs and attached resources. Dispatch command executes a compute pipeline in the context of inputs and attached resources. I have absolutely no idea what these mean, but I'm gonna go on. It does not require an entry point. There's such a program cannot be executed by the API because an entry point is required to create a GPU programmable stage. Syntax notation describes the convention of the syntactic grammar of WGSL, italic text, both sides, syntax rule. Okay, can you give me dummy examples, like simple examples, how you do things? Any example, a simple one. Texture sampling. I don't want texture sampling. Okay, I can go mock examples here. Triangle. What else do they have? Transparent window, shader, patient zero. It's still very simple stuff. I mean, it's good, but I want custom renderer. Okay. Fail. What is group? What is binding? I think I have to ask these things from AI. It's not helpful. I mean, it's gonna take a really long time if I'm going to do this like one by one. Let me go back to the code. Okay, let's go back there. Your specific case. Okay, so location 0. Okay, what does location 0 do? Location 0 here. It's tells the GPU write this color to the output attachment number 0. Why is it 0? In the Zig setup line, you define a list of color targets. color target, frame buffer format, blend, blend state. Okay. Location 0. If I was to define another target here, that would be location 2. So targets, right? I guess. So targets, it's some array of location 0, location 1, and it's here we have one only, so that's the location 0 color target. Okay, so we can do 3 texture at once, at least for some modern. We can have multiple render targets, location 0, 1, 2. 0 is for color, 1 for color, 1 for normal, 1 for glow. I have absolutely no idea what these things are, so okay, I'm gonna stick to this one. Vertex shader, fragment shader. Okay, let me go back. Um, and then shader module, fragment state. Okay, so the first thing I want to do, I want to be able to have multiple colors for the triangle. So each corner of the triangle, I want to have them have multiple colors, each vertex. I can ask the code from, AI, but I want to understand it. So that's why put in time. Like I already see the code like in AI, but I don't understand it, so I'm gonna have to take time. And um, this is the time for me going to eat and rest a little bit until I will come back in 2 or 3 hours. So I will be back in. Right now it's 12, and I will be back in 14, around 14:30, like two and a half hour later. Thank you for watching. Don't forget to follow the channel and put a like on the video. It will help us a lot. And see you again. Take care. Stay safe. Bye bye.